Hello all, this is the Pencrest High School AP Physics 1 video series. This is video 5A, Introduction to Work and Energy. Now we're going to start this section with standard textbook definitions of work and energy, although you're going to see right away why I'm not a big fan of these. Work is typically defined as transfer of energy from one object to another. Energy is then defined as the ability to do work. Now you can see that this is a bit of a circular argument. So I have never been really very pleased with these two definitions. We're going to come up with a better definition of energy, and then we're going to see that with this better definition of energy, the definition of work actually becomes fairly useful. Most textbooks begin with work, but we're going to begin with energy because it's associated with quantities and concepts that we're already familiar with. So we're going to describe energy as the state of an object or a system of objects that's based on the position and the kinematics behavior of those objects, where it is or where they are, and what they're doing kinematically is going to tell us what kinds of energy are present and then how much of each one. We're going to describe the object or objects as having or possessing the various forms of energy. Now there's a lot of different forms of energy, including electrical energy, nuclear energy, radiation, heat, chemical energy, and more. We're going to focus on the types of energy that are considered mechanical energy. These are kinetic, gravitational potential, and elastic potential energy. You've probably heard these terms before. We're going to go a little further with them now than you have before. So first we'll look at kinetic energy. Kinetic energy is the easiest to identify. It's the energy of motion. Simply put, if an object is moving, it has kinetic energy. We're going to get to how much later on. If the object is stationary or it's at rest, it doesn't have any kinetic energy at all. Again, that's the easiest one to identify. We also have what's called gravitational potential energy. This is energy that's associated with vertical position. Technically, this requires more than one object because of the nature of the gravitational force, which, as we know, acts between any two masses. Typically, the other object is the Earth because most of our problems take place here. You might consider a ball that's thrown up into the air. When its position is above the ground, we would say that the ball-Earth system has gravitational potential energy. In practice, we're only going to consider what the effect is on the ball, but for some reason this ball-Earth system idea is a big deal to the physics committee of the College Board. So again, we're going to see how to calculate how much energy there is a little later on. It's called potential energy because it could be converted into kinetic energy. In other words, it has the potential to be changed into kinetic energy. Now we also have elastic potential energy. This is energy that is associated with stretched or compressed objects. We've all been shot with a stretched rubber band. You tend to instinctively flinch when somebody points one at you. But anything that's elastic, springs, bungee cords, trampolines, any object that can visibly stretch or compress can contain or have elastic potential energy in it. We're going to look very thoroughly at elasticity and elastic behavior a little later on. We're also going to look at how to determine the quantity later. Again, elastic potential energy is called potential energy because it can be converted into kinetic energy, like when the person shoots the rubber band at you. Now, much of our analysis is going to depend on the ability to identify the presence of one or more of these three forms of mechanical energy. In other words, we need to be able to look at a particular system or situation, and we need to determine if it has kinetic energy or gravitational potential energy or elastic potential energy, or maybe some combination of the three at any particular time, based purely on the description of the behavior, maybe a diagram. We just need to be able to tell if these forms of energy are present. Okay? We might look at a particular situation and ask ourselves, is the object moving at this particular time? If it's moving, then we would say that it has kinetic energy. We then would ask if it is elevated or raised above the ground at that time. If it is, then we would say that it has gravitational potential energy. We would look for any type of elastic object or a spring and ask if it is stretched or compressed at that time. If yes, then the elastic potential energy is also present in the system. One form of energy does not depend on the others. So an object or a system of objects can have one form of mechanical energy, or two, or all three, or potentially even none at all. Now, you've probably heard the statement, matter or energy cannot be created or destroyed. This is true, and it's one of the laws of thermodynamics. We can, however, change one form of energy into another, and we can transfer energy from one object to another. When we transfer energy from one object to another, we say that this is doing work. We're going to get to more careful analysis of doing work a little later on, certainly quantitatively. But for our purposes now, when we transfer energy into a system, when we add energy to it, or when we take energy away, that's called doing work. All right? So that will do it for the introduction. Next up is quantification of work and energy. Until then, enjoy. I'll see you again soon.